In this video, I will take you through my favorite Android architecture to build solid, scalable, and testable Android apps. First of all, what is an app architecture and why do we need to care about that? The best example on this is a building. Let's imagine that we want to build a building that is consists of 100 floors and you were asked to start building it. Are you going to start building the first floor, or are you going to start building a strong foundation that can support the 100 floors? The answer obviously is to start building a strong foundation because everything that comes later relies on the foundation of your building. If the building has a strong foundation, then you can keep building more and more floors. But if you have a weak foundation, the building will end up by falling down. And the same thing we have in development. In order to build scalable and solid apps, we need to take care of the foundation of our app and determine how the different components interact with each other to ensure that our app will not fall down like the building that has weak foundation. And that is what an architecture is. So in this video, I will show you how to structure your Android app in a way that makes it scalable and testable by following the best practices. So let's get started. Okay, so here's how this video is going to work. First of all, I'm going to introduce you to this architecture, to this block diagram. Then I'm going to build a simple app that uses this architecture to show you the different components and how we can put this architecture in action. So as you can see, this is the block diagram of this architecture. I know that it might look very confusing for you. If you have never implemented these layers and any of these blocks, it might look very hard, but I promise you that it will make more sense when we actually implement our app. Okay, so as you can see, this architecture has three main layers. The first one is the presentation layer, then the domain layer, and the data layer. So each one of these layers have specific job, and there's a reason why we divided it into three layers. So in the presentation layer, in this layer, we basically put the UI and the view model and anything related to the UI. So anything will be visible to the user will be inside this layer. So the UI, like screens, like dialogues, models, bottom sheets, everything that is visual to the user will be in this UI diagram. The view model is basically a state holder. So we use the view model to handle a click, for example, to save the state. So for example, if we have a login screen and we have the email text field and we have the password text field, so we want to keep the values of these text fields in a safe place, and that is the view model. So the view model will just save the states that we have in the UI. So again, in the presentation layer, the UI uses the view model and the view model returns the state to the UI to show it to the user, and we will see that in action. Don't worry. Then we go to the domain layer. So in the domain layer, we keep the constraints and the rules of our app. And by the way, we only put abstraction code. So no implementations, no framework code, like you don't need to use libraries in the domain layer. It must be pure Kotlin or Java code. So do not use libraries, and as I said, just abstraction code. So as you can see, we can put repositories, managers, models like data classes, and all of these basic things. By the way, the repository here will be an interface, so we will be using interfaces a lot in the domain layer, and as I said, data classes as well. So the last layer we have the data layer. So in the data layer, as it says, it deals with the data. It fetches data from a remote API, or it fetches data from a local database, or it just implements the repositories and managers that we have in the domain layer. So the data layer is all about implementation, the domain layer is all about abstraction, and the presentation layer is just to show visible information to the user. So as you can see, we have some relation here between the presentation, domain, and data layer. And the presentation layer here depends on the domain layer. The domain layer depends on the data layer. And again, you're going to see that in action when we build our app. And I hopefully don't forget about this, so I'll explain everything when we build our app. And one last block I want to mention is this event bus. So this event bus is used basically to expose some events to the UI. So let's say we have a login screen and the user just put the email and password in there and clicks on login. So you're basically going to create or you're gonna call a function from the view model. The view model then will call that function from the repository, and after that you will return a result to the view model. And when you got the result from the repository, now we're inside the view model, we want to tell the UI, okay, the user is logged in now, please go to the home screen, for example. So this event bus will do that. We will basically populate an event to the event bus and the UI, and the event bus will tell that event to the UI. Not only that, we can use the event bus also to just send toast, for example, from the view model to the UI, or show a dialog, or show a snack bar, a lot of things. So you will see that as well. Now, before we go to the implementation, let me just go with the flow in this architecture, then we will implement our app. As you can see, the UI layer, so let's say login screen. So the user basically fills the email and password. Then the user calls the login function inside the view model. So this arrow, let's say that this arrow is the login call. Then the view model will use the login repository to also call the login function from the repository. Now the repository will use this remote to just make the remote call to the server and return a result, and then this repository will return something called either. So I'm gonna explain that. Then the view model get this either and change the state and send it back to the UI. So this is how this architecture is going to work. And now enough talking, let's actually implement it and put it in action. Before we implement it, let me show you what we're going to build. So as you can see, just a simple screen that features some products from a fake API. So as you can see, we're just gonna show a list of products, and we're going to apply the architecture that I discussed with you on this simple app. Okay, so create your compose empty project, and we want to add some dependencies. So on the one hand, we want retrofit and JSON converter just to be able to fetch data from our API and convert it into data class. We also want coil for the images, and we also want some libraries. So let me just copy and paste. This arrow, we need it because in the diagram I showed you, I told you about this either. So this either will get it from this library which called arrow. Retrofit here, coil for the images, and Dagger hilt for dependency injection. Now we want to add this capped plugin, so let's do that. I'm gonna paste these in here for capped and Dagger hilt. By the way, you will find all of this setup in my repository. You will find the link into there. So just copy these and paste them in your project. Now we want to go to the Gradle file, the project level 1, and we want to also just paste one more plugin in here, and that is for Dagger hilt. So paste it in here, click on sync now, and then we are good to go. And before I forget, first of all, I just want to ask for the internet permission because I normally forget that. So let's do that firstly. And now let's start our architecture. We can just delete these default things from Jetpack Compose, delete the creating function. And the first thing you will always need to do whenever you create your project is the packaging structure, which is a very important topic. So how the packaging structure works with this architecture is by dividing the project into features. So each feature will have its separated package, and then in each feature package we will put the 3 layers I showed you in the architecture. So in our products app, the main feature we have is the products or the store feature. So we can create now a package inside our root package and call this store. Another feature, for example, would be a chatting feature. If you want to allow the clients to chat with the store, so you would just create another feature here called chatting. That is just an example. So let me delete this. So the feature basically is just set of functionalities that is related with each other. So in the store, for example, we can fetch the products, we can make orders, we can do all of things that is related to a store. Now inside the store feature, as I said, we're going to create these 3 layers: presentation, domain, and data. So let's create these 3 layers, and each layer will be inside, will represent just a package. So presentation, domain, and data. Okay, now how do we start? Where to start in? Well, whenever you work with this architecture, you always need to start from the domain layer because you're going to need the domain layer in both the data and presentation layer. So we're just gonna start from here, and we wanna start by creating the model classes. So the model classes are just, typically there are data classes in Kotlin. So we're just gonna create here a package called model. And inside here, we're going to create our classes. So what we have is just class that called product that need to hold the product information. So for that, we want to open Postman here real quick and send a quick request to the API. So this is the API send, and this is the response that we'll be getting from the API. So as you can see, each product has this information, and we want to model them inside a data class. Val ID, and that is an integer. We're going to have description. Make sure that you type it the same way you get from the response. Otherwise, you will get an error. No, we have title and price before the description. So title string, and we have the price, which is just a double. Here we have the category, so let's add that. String, we have the image, which is also a string, and we have here another object which is called rating. So let's create data class for that called rating. In here we're going to have rate, which is double, and count, which is an integer. So rate double count, which is an integer. Let's put that in here. Rating, which is type of rating. Now let's go back to the architecture. As you can see, we created the models. In our case, we have only one model. Now let's create the repository. So let's create a package for the repositories. Call this repository, like that. And we want to create the products repository. So products repository. As I said, only abstraction code. We don't want to do any implementation inside the domain layer, and that's why I created it as an interface. The implementation of this interface will be inside the data layer. If you're wondering why do we do that, it is basically to achieve a principle that's called depend on abstraction, not on concretion. That means you always need to depend on abstraction classes, not on the implementation classes. And that is because of changing. So let's say if you implement this repository with a retrofit, and then you, for some reason, you want to change the library to cater client, for example. So other classes that depends on this interface will not need to be changed because they just depend on abstraction, not on concretion. And that's the main reason why we always need to just have interface, and we implement it inside the data layer. Okay, so for this interface, we want to fetch the products, and that's the only function we're going to have in here. So suspend function get products, and now we want to determine the return data type. So let me go back to the architecture. As you can see, the return data type here is an either, which we basically get from the arrow library. And now let's return either. And I'm going to explain how this works. Let me just return here. And here we need to pass two generics. In this either library, we basically have two values, left and right. The left value represents the error, and the right value represents the success case. So for this get products function, what goes wrong should be mapped to the left side of this either block. So in this get products function, if something goes wrong, then we will return the left value of this either. If everything goes right, we will return the right value of this either. So you can imagine this like a box that is split into two parts. The part on the left, that is the bad part that we don't want, and the right part is the part that we want. Now, as I said, the left part is going to have the error, the right part is going to have the success case. So for the left part, now we want to determine what do we want to return in case we have an error. And for that, we're gonna create another class in here inside the model class to just hold the error information. So let's create a class here, call this network error. So this is just a data class that is going to hold the network errors or the data of the network error that we get from that functions deal with the internet. So we want to determine what type of error we got. We create an error here, and we want to create an enum class here to determine the different errors we have. We'll call this API error, and we want to just pass a message with a string. Now let's create different type of errors. For example, network error. We return here for this message, for example, network error, unknown response. We pass that in the message. And let's also create unknown error. Now this error will be of type API error. And we also want to pass the throwable or the exception. And this might be null, so we make this optional. Now let's get back here. So as I said, on the left part, the error. So let's pass network error here. And on the right part, the result that we wish to get from this function, which is just a list of products. And that's it. And that is it for this repository. And I think we're just done with this domain layer. So let's close it. And now let's move to the next layer, which is the data layer. And now let's go to the data layer and implement the remote API. So as you can see here, we have this remote, and inside here, we're going to implement the API. So let's create here function package, sorry, not a class. We want to call this remote. And inside here, we're going to create our API, which is just, let's call it products API. And with the retrofit, so that is just represented by interface. So we can call this products API. Now you might wondering why we don't make this an implementation. Why am I making it an interface? Because I just said that the data class, the data layer is all about implementations. Well, that depends on the library that we are using, because retrofit just requires us to create an interface for the API. Other libraries might need you to implement that API by yourself, but just depends on the library. Now here we're just gonna create a get request. The route is a products, I think. Let me make sure. Yes, that is a product. Now we want to make a suspend function to get the products from our API. Get products, and we return a list of products like that. And that is it for this API. Now, next thing, if we go back to the architecture, you can find remote, local. We don't have local in this app, so we're gonna skip that. We're gonna go to the implementations. So what we want to implement is everything inside the domain layer. In our case, we want to implement this repository. So let's create a package here called repository. Now we want to implement the repositories inside this package from the domain layer. So we create a normal class called products repository. So the same name of the abstract one we have in the domain layer, but this time we add implementation at the end of the name. So don't just write the whole word, just impl is enough. Now we implement the products repository from the domain layer. And here we are required to implement this function. Let's click enter. And now to be able to get the list of products, we of course want this API, the products API. So we can just pass that into the constructor here. We can say constructor private val products API. And now we can just use it to get the list of products from the API. Now remember that we are dealing with networking, and in networking, we normally use try and catch to catch errors. But in this architecture, I prefer not to use try and catch anymore. You might now wondering what am I saying is just crazy, but let me tell you that that is the main reason why I used this library. Well, try and catch has several issues that I want to talk about in this video, and let me just talk about them now. So the first issue we have with the try and catch is that if you have a large code base, you might don't know where to use try and catch exactly. So should I use it in repository? Should I use it in the view model? So you don't know where to catch errors exactly. The other problem with try and catch is that you want to know if the function is actually throwing an error or not. So you want to know if you should actually use try and catch. And how do you know that? Well, you go into hope that the person that wrote the other function, the programmer that wrote the other function just left you some documentation. Now you are hoping, and hoping in development is not good. And the last error, which is the most important error in my opinion, is when dealing with Kotlin coroutines. So let's for now just catch it with try and catch. And let's say in here you just call products api.getProducts. And here you just, for example, say print. This is wrong with coroutines because when this function gets cancelled, what basically happens is that it throws a cancellation exception, and we are here just catching every exception, so this function won't be able to get cancelled. If you want to make it work with try and catch, you need to do this. You need to say if the exception is of type cancellation exception, then we just want to rethrow this exception. Now this causes you a lot of pain, and I personally forget to do this a lot. So all of that problems are just solved by this either library. So now we can just remove all of that. We can say either.catch, and here we just make the function, or we just call the function that might throw an exception. To say product api.getProducts, and we don't want to forget to return. Now, as you can see, this complains. The reason is because the right part is returned correctly here. So what inside this either catch will be automatically returned on the right part of this either, and what's on the left will be returned as throwable, as you can see. Now we want to map this throwable into our network error. For that, we can go create another package here called mapper. So here, mapper, we can create a class or a file. Select file, mapper. And in here, we're basically gonna map our throwable into a network error. So we can say throwable. This is just an extension function to network error, and we return a network error. So first of all, we want to get the type of error. So we can say the error equals when the exception we get is an IO exception. Then that could be, for example, or I think that is a network error, is HTTP. Oh, we forgot the angle here. And if that is an HTTP exception, then this could be, then the error is API error dot unknown response. Else than that, we don't know the error, so we return API error unknown error. Now we can say return network error, and here we can say error equals to error and the t equals to this. Get back here and we can say map left. So we map the throwable to our left part of this either container. We can say it to network error. Now all the errors are gone. So let me go through this. We don't want to use try and catch, but we use this either.catch to solve all the problems I talked about. So the last line inside this either catch will be returned to the right part, and if something goes wrong, a throwable will be returned in the left part. Now we want to map this throwable on the left, so we create this extension function to map it into our network error. Now note that this either library have like more things, more complicated situations than this, and for that I'm going to create a video about it in the future. So for now we're good with just this either.catch, and as I said, in the future I will create a separated video on this either library. Okay, now that's it for our data layer. Finally, which is the fun part, we're going to implement the presentation layer. So let's close all of this. Let's create a package here. So for each screen, we basically create a package, call this products screen, and let's create that screen, product screen. Let's create a composable function called product screen. And now to make this screen testable, we want to separate the content of the screen from the screen itself. So we can make this internal. So we just access it from the current file or package, module, sorry. And then we can create products content. Now again, I created this to make this one testable, so we can test the UI, because what we are going to get inside here is just states. We're not gonna pass any view model or all of that. The view model will be inside here, the nav controller or anything else will be inside this screen, but this content will just have UI things. Now we want to create a data class to hold the states. So let's create that. We call this products view state. Make this data class here. And so in this data class, first of all, we want to have a state is loading, boolean initially false. So for each one of these attributes, you need to pass an initial value because these are states and you want to determine what to show initially for this state. So here the products, list of products, product, and that will be an empty list. Error, that is a string, optional. I don't know, you might need to show an error on the screen or send a toast, so you will see that. By the way, we have not implemented this event bus yet. We will implement it in a bit when we finish from the UI and go to the view model. We'll implement that in there. Okay, now let's get back to the screen, and basically here we are going to pass a state, which is a products view state. So first of all, we want to show the dialog if it's loading, and that loading dialog is going, of course, to be reused in other screens. And for that, inside the presentation package here, we create another package called URL. So anything inside this URL package will be used among all of the screens we have. Inside here, we can create components. So UI components. And now we create loading dialog. So we can say loading dialog composable. So we're trying to make this as reusable as much as possible. Is loading here. And now if it's loading, we basically show the dialog. On this mess, we won't implement that because we just have if properties. Let's change that dialog properties, and dismiss on when I click outside, make this false. Here we just have a box. We give a modifier width of 200 dB. Modifier, import dB. And we clip this to rounded corner shape. Pass 15 dB for the corners. And we add a background of color.white. Oops. Background. Okay, we need to get out of here. Then add a background modifier, color.white. And let's format that. Then here we're gonna pass content alignment to center the content in the center. Finally, we can just call circular progress indicator, and we want to add some padding. Let's add 10 dB. That's it for our loading dialog. Let's get back to the product screen. We can call that in here. So loading dialog, we pass state.is loading. Now for our screen, we can layout it with a scaffold. And this is an experimental API, so we want to add this annotation. We want to pass a modifier to fill the max size. We want to have a top bar. Again, this top bar might be reused in other screens, so we just create it inside the components package here. As I said, you always need to make reusable components in Compose, which is a huge advantage. So we're gonna use that. So my top bar, my top bar. In here we pass whatever you want to pass. I'm gonna keep this simple. We're just gonna create simple top app bar. The title. Let's add the annotation here. Here would be just a simple text. We pass the text. Pass the title. And let's add some shadow. Elevation would be 5 dB. Okay, let's get back here and let's pass the top app bar here. That would be my top app bar. We pass products. Okay, here finally we want to show the list, and we are going to create that with a lazy column. So we can say lazy, or no, we're gonna create that as a staggered grid, vertical one. So lazy vertical staggered grid columns. We want to show two products beside each other. To do that, we can say staggered grid cells, fixed, that's 2, content here, delete that and open it from the outside. It is complaining. Why? Because we want to use the internal padding. Let's just create a new comment or a new line. Then we can say modifier.padding top equals it.calculate top padding. So we just want to make sure to avoid the height of this top app bar. Now let's just play a little bit with the arrangement, horizontal arrangement, space, say arrangement spaced by 10 dB, and vertical, we want to add some spacing between items vertically, and that is 10 dB. Now we just want to loop over our items using this items function state.product. We want to import that now. So import this extension. Here we get our product. So for each product, we want to show it. And for that, we're just going to create the product card, how it looks like. We would like to create it inside the product screen because that is something for this screen. We create components here. And let's call this product card. Select file, create that composable. In here we want to get we want to pass modifier, give it a default value, and we want to also send a product. Now this will just be a card. We send the modifier, we add a shape, which is a rounded corner shape, 10 dB. We add elevation, card defaults, elevation or card elevation. Let's add default elevation 2 dB, format that. And now we add colors, card defaults dot card colors. We just change the container color to white. Now the content of this card will be just a column. Modifier is modifier dot padding 15 dB. And now we want to add the image. So we use coil for that. The model would be the URL. The content description, let's pass null for now. Modifier equals, we want to fill the max width of this image. And we want to make sure that it is a square. So we add aspect ratio of 1f. Then we want to add content scale. We want to fill the bound. Now we add spacer of 5 dB. Finally, we add the title of our product. And we add also style to this text, material theme. Typography, title, medium. You can of course add the previews, but just for the time of this video, I'm not gonna do that. Now we want to create the view model for the screen. So inside that package, we call this products view model, extended from view model. We have not implemented Dagger hilt yet, but I'm just gonna inject this. We will implement the module in a little bit. So inject, or I'm not sure why I'm not getting it. Let me just add the hilt view model here. And here let's add inject. Okay, I'm gonna import that later. Yes, now it shows. And we want to inject the products repository. Now, a very important thing now, remember when I told you that we want to depend on abstraction. So here, do not call the implementation. You should depend on the interface inside the domain layer. Because if we go back to the diagram, as you can see, the view model here depends on the abstraction inside the domain, not on the implementation. So as you can see, this depends, the presentation layer here depends on the domain, which is just the abstraction, and that's what we did in here. We depended on this abstraction interface. Okay, now let's create a function called get products. And before that, we also want to have a state for the UI. So we can say private val, private, not protected, state equals mutable state flow. We pass the initial state, and here we get that as an immutable version. So here we just make sure that we don't expose the immutable one, and we just make an immutable version of this state just to apply or to achieve the encapsulation principle. Okay, now we wanna launch a view model scope, and we wanna say products, or before that we wanna emit the loading state inside our state. So update. In here we get a reference of our state, and we wanna send back a new object. So we just wanna take a copy of our state, and we wanna make the loading to true. In here we wanna call the products repository, and we wanna get the products. So now here we get the either type that I told you about. So remember, the right part is the good part that we want, and the left part is the error or the bad part. So we can say on right and on left. Now on right we get the products, and we can just update our state. We can say products equals to product. On the left part, we get the error here, and we can just update our state as well. It dot copy error equals to error dot, let's get the message or the type of error, then we get the message. And now we don't want to forget to stop the animation, or sorry, the loading. So let's copy this, change the loading to false. Now one more thing, let's say that you want to show a toast message just to send an event to the UI and show a toast message. So for that, we're going just to implement this event bus. So this event bus will be outside of the feature because it might be used for multiple features. So the same thing will be used for more than just one feature. We just create a new package here for this case, called this URL, and we create, make this event bus class, and no, let's make this an object, not a class, because we want this to be a singleton, of course. It's very important to make this as an object. So private val events equals to channel. So this channel will just send the events to the UI. Don't change the capacity, we're good with the default one. We want to receive this as a flow, and now we want to have a spend function to send the event. The event here is just of type any. We can say events.send the event. We can here create sealed interface called event. In here we just wrap the type of events we have. So for example, you would have a toast event. For the toast, you want to pass the message and return an event. You might also have a snack bar. So for example, snack bar. For the snack bar, you would have also the message or dialogue. For the dialogue, you would have title and text. But in our example, we just want to have a toast. Let's get back to the view model. And now we want to just use that bus event or event bus to send our events. And I want to make this simple by creating an extension function. So inside the presentation layer here, inside the URL, let's create a class called view model extensions. View model ext file, and that would be just an extension function of the view model called send event. This will receive a type of any and will launch a view model scope. And here we just call event bus dot send event. We send the event. Get back to the view model. We just need to call send event inside the left. So that's the error. Make sure we're inside the left. So here, and the event that we want to send is toast message. So event or events. This one dot toast. We want to send a message with this toast. Now we can go back to the screen and we just here we need to get a view model instance and call this products content. So let's do that. We can just get in the constructor, say view model, products view model equals to hilt view model. And here we can get the state. We can say view model dot state collect as state. I think we need just to update the dependency or we are missing one dependency here, so let me just add it real quick. Okay, so this is the dependency. As you can see, this one responsible is just to collect this this state with lifecycle aware. So state, we still don't get that. I think we just need to rebuild the project. Okay, we got this issue, which is a compatibility issue. So let's go to this module file. So here it requires us to change JVM target to 17. This one as well. So version 17. This one is just the Java bytecode compiler version. And now I suppose that if we build the project, we won't get any issue. Yup. Let's get back here. Hopefully now we get that collect with collect as okay. So I think I added the wrong dependency. Let me just check that real quick. Okay, I found the dependency. This one, I'm sorry about that. So let's click on sync now and get back here. Now we're supposed to get that function collect as state with lifecycle. This one. Okay, now we can call products content. And we can send our state. And that is it. Okay, let's just use the delegation way here and import this. And that is it. That's almost everything. One thing is missed is the Dagger hilt module. So in the root package, we create another package called DI. The DI won't belong to any feature because the retrofit instance that we provide might be used in the store feature and other features. That's why we created in the root package. In here we just create object, call this app module. Let's use the install in annotation and module annotation. So first of all, we wanna provide the API, the products API. So let's say provides. We want that as a singleton. provide products API, which returns products API. So in here, we just say return retrofit dot builder. We call build, and we create our products API. Now let's configure this in between. So here we want to add the base URL. We want to make this as a constant. So inside its URL, let's create a constant object. We make this an object. We can say const val base URL, and we pass this base URL. Get back here. We want to say base URL, and we want to add the converter factory. Converter factory. We just add JSON here. And that is it for this API. Now to provide the products repository, we have two ways, either by just providing it in here, or the other way, which I like, whenever you have an interface that you want to provide, just gonna create something called, for example, repository module. We make this a module, and again, call install in singleton. In here we call bind. So this just works for interfaces, and we want to make this singleton. We make this abstract class, an abstract function here. We call this a bind products repository. Now in here, repository. Now in here we pass the implementation to this function, and again we want to depend on the abstraction. So products repository, it's the interface, return the interface. Now we go to the implementation of this one, and in here we just need to add this inject word. And one more thing, the application class. So my application, extended from application. So basically this is how you set up Dagger hilt. If you don't know Dagger hilt, I have no words for you, but go and watch a video about that. In here we just need to add hilt Android app and add this to the manifest. Now everything is almost ready. One thing is just to call the product screen here. But we have not handled the events that we get from the bus event, from the event bus, sorry. So let's do that inside here, inside the main activity. So the way how we can collect events safely in the UI in Compose is by a launch effect. And the key here is the life cycle. So let's get an instance from that. To say life cycle is local life cycle owner current.lifecycle. We pass that in here. And now we say repeat on lifecycle change. State here is so basically we only want to collect the events when we are in the started state of our activity. So we can say state.started. And in here we get a routine scope. Now we can just collect our event bus. So event bus, we say events collect, and here we check for the type of event that we got. Let me rename this. So if event, or let's use when, or no, let's keep an event. If event is type event.toast, we want to show a toast message. The context is this, we mentioned the main activity, and the text, we get it from the event. I suppose that this is everything for this app. Let me just launch it to make sure it works. Okay, surprise, surprise, we got an issue from hilt. Let's see what is that. Hilt inst. Okay, we need to add the Android entry point to our main activity. Let's try again. Still got an issue. Okay, the issue is because I forgot to pass the class here to which class I want to bind this module. So we just wanna make this singleton. Okay, we forgot to call the function. So let's go back to the view model. And here inside the init block, we say get products. Let's relaunch the app. And here's dialog. Let's see our products. We did not get any products. Again, I keep forgetting about stupid things. So here we did not call the product card. Let's call the product card. Let's pass the product here. And now if we launch the app, we should see the product. And here you go. So as you can see, here's the product. We have some colors issue in the card. Let's check that. Yeah, here as you can see, content color. So we're gonna change this to container color. Launch again, but as you can see, we were able to just load the product successfully with this architecture. Here you go. So here's the app at its final result. Now we want to test the event. So let me close it and let me turn on the airplane mode, launch the app, and we are supposed to get, yep, we got the toast message, network error. And that seems like it works perfectly fine with no issues. Okay, so that was everything about this video. It was a very long video, I know, but trust me, you just learned how to build solid and testable apps, so you can use this architecture in your apps. Thank you so much for watching this one. If you enjoy my content, then click on the like button and subscribe to my channel. Join my Discord community, and you are very welcome. So I hope you have a great day. Catch you in the next video.